Welcome back to Advent of Code 2024, day 21. All right, 21. Here we go. Keypad conundrum. Oh, sounds like something a bit more different this time. As you teleport onto Santa's reindeer-class starship... Okay, that was from an intercode problem. That was from 2019, the year of the intercodes. The historians begin to panic. Someone from their search party is missing. A quick life-form scan by the ship's computer reveals that when the missing historian teleported, he arrived in another part of the ship. The door to that area is locked, but the computer can't open it. It can only be opened by physically typing the door codes on the numeric keypad on the door. The numeric keypad has 4 rows of buttons. Visually, they are arranged like this. Unfortunately, the area outside the door is currently depressurized and nobody can go near the door. A robot needs to be sent instead. The robot has no problem navigating the ship and finding the numeric keypad, but it's not designed for button pushing. It can't be told to push a specific button directly. Instead, it has a robotic arm that can be controlled remotely via a directional keypad. When the robot... Yeah, I need to get my coffee. Alright, when the robot arrives at the numeric keypad... Wait, so there's a directional keypad. 2 rows of buttons. Gap. Up. A. Left arm right, okay. When the robot arrives at the numeric keypad, its robotic arm is pointed at the A button in the bottom right corner. After that, this directional keypad remote control must be used to maneuver the robotic arm. Up, down, left, right causes it to move its arm one button in that direction, and the A button causes the robot to briefly move forward, pressing the button being aimed by the robotic arm. For example, to make the robot type 029A on the numeric keypad, one sequence of inputs on the directional keypad you could use is... blah blah blah, okay. There are 3 shortest possible sequences of button presses on this directional keypad that will cause the robot to type 029A. Unfortunately, the area containing this directional keypad remote control is currently experiencing high levels of radiation. Wait, what? Oh, I see. So the numeric keypad needs a robot as well. So when the robot arrives at the directional keypad, its robot arm is pointed at the A button. After that, a second different directional keypad is used to control this robot. Unfortunately, the area containing this second directional keypad remote control is currently minus 40 degrees. Another robot would need to be sent to type on that directional keypad too. Unfortunately, the area containing this third directional keypad remote control is currently full of historians, so no robots can find a clear path there. Instead, you will have to type this sequence yourself. Were you to choose this sequence of button presses, here are all of the buttons that would be pressed on your directional keypad. Oh my god. Fine. Okay. It is important to remember that these robots are not designed for button pushing. In particular, if a robot arm is ever aimed at a gap where no button is present on the keypad, even for an instant, the robot will panic unrecoverably, so don't do that, alright? All robots will initially aim at the keypad's A key, wherever it is. To unlock the door, 5 codes will be needed typed into its numeric keypad, for example. For each of these, here is a shorter sequence of button presses you could type to cause the desired code to be typed on the numeric keypad. Okay. The historians are getting nervous. The ship computer doesn't remember whether the Mysterian historian is trapped in the area containing a giant electromagnet or molten lava. You'll need to make sure that for each of the 5 codes, you'll find the shortest sequence of button presses necessary. The complexity of a single code is equal to the result of multiplying these 2 values. The length of the shortest sequence of button presses you need to type in order to cause the code to be typed on the... Okay, fine. Numeric part of the code... Okay. Fine. What is the sum of the complexities of the 5 codes on your list? it's not quite as trivial as, well... Alright then. We actually need A in... Okay, fine. So this is kind of easy as long as, say, the shortest sequence for a particular keypad necessarily equates to the shortest sequence in the next level of keypad. And I think that's true. Well, it's... I mean, whenever you want to go from one number to another number, it's usually... If I want to go from 1 to 9, I have to go right at some point, I have to go up at some point. So right and up absolutely have to be pressed at some point. There's no reason to ever go left and down in that case. So it makes sense to first sort out your verticals. Well, not necessarily. If you're in the final row... Okay, maybe we just do what I think is right, and see if it works. Like, I don't see any reason why you wouldn't just do the obvious thing and, like, move up, down, left, right via the shortest Hamming path. It doesn't really matter whether you go up first or down, right first, because you start at A in the numeric keypad. And like, the only situation where it would matter would be if you wanted to... No, let's say you wanted to go left and up to get to your place. So you could go over to the left and then go over to the up and then go to A. Or you could go to the up, then go to the left and then go to the A. Those are the same. So as long as you're minimizing the number of times it doesn't seem to matter which ones you go for first, as long as there's only 2 maximum. Okay, fine. Let's just get started on this then. In this case, the input has the same size as the example input, so... Oops. Okay, so... Okay. Those are the codes. Oh my god. Alright, so we want a method which okay. We want two methods here, basically. We want a method which get get directional presses for numpad in order to type a code. And then we want this method. Get directional presses for dir pad in order to type a sequence of directional buttons. So the idea is you transform your code into dir presses, and then you apply this method to it like 3 times or 4 times. We'll figure that out later. And then that should get you a sequence, if my assumption is correct. I'm worried that it might not be, but I don't see anything wrong with this. All right, so we start at A, right? Always, in all keypads. Yeah. All right, let's use our pos class. But it's going to be simplified. Like, mostly just that. We probably actually want subtract. I think part 2 might have us type them in any order or something like that. That'll be more complicated because then it's not obvious what the shortest path is. Like, when we're at 7 and we have to type 8 next, obviously we need to move our hand to 8, right? There's no ambiguity about that. But if we could type 7, 8 in any order, then the question becomes whether we go 8, 7 or 7, 8, and then it does matter. But okay, we'll see what part 2 is. have equality. I don't think we'll use it, but you should always have equality. We're all for equality, yeah. Okay, so we want numpad. It's gonna be so we just map the characters to the pauses. So let's say pause 0, 0. 0, 1. Pause 0, 2. Okay, just keep doing this. So we've got 789, 4, 5, 6. Then we've got, hang on, one, 2, 3, and that's 2, 2, 2. And we want 0. So that's 3, 1. And then A. 3, 2. So that's the numpad. And the dir pad is similar, but will be essentially so be up A. So that one is gonna be 0, 1. A is gonna be 0, 2. And then we got left and right, the next row. So we've got left 1, 0, down 1, 1. Right, 1, 2. All right, hopefully I typed that correctly. Okay, so get dir presses for numpad. So we're starting from A. So we just say pause equals numpad A. And the sequence is going to be, we're going to append there. So for car in code, destination is going to be numpad car. So we're at pause, want to get to dest. So the delta is dest minus pause. So this delta tells us, okay, so if we are on the bottom row, we may not want to go all the way left. Right? Otherwise, we can. So okay, so should we just say if we're on the bottom row, we'll do vertical moves before. Okay, if pos dot I equals 3, we do vertical moves. Okay. So for in range pos, so it's going to be delta dot I. So that's the direct. That's which way we have to go. Seek dot append. So it's going to be up if, or let's say down if delta dot I is positive, else take the absolute value. So for example, it's -2, we'll do this 2 times, but we'll go negative. So you go down if it's positive. I mean, that technically is invalid because we're on the bottom row. Doesn't matter, we'll keep it because this is the same as what we'll do later. So else up symbol. Okay. And then we do horizontals. So it's going to be right if delta dot j is greater than 0, otherwise left. So otherwise do horizontal moves first. That will ensure that we can get onto the bottom row safely. So we'll just swap these around. I don't know if that's just a cleaner way of doing this, but there does need to be a difference. You can't, there is not one order for everything. So it'll be that, and then that. So that is the sequence of, that's the sequence we do to get to the character. And then once we get there, replace pos with dest. And then we need sequence dot append A in order to press the button. And that character is done. And then do we need to return to A. Oh no, we do return to A, but because the code always ends in A. And also, it didn't say we need to return to A, but we happened to return to A anyway. So, yeah, because it wouldn't matter, would it? Okay, so that should be it. Should we test this and see if it matches? So this is a good chance to actually use the test example to begin with. So let's just replace this with that. Print dot join. So it's going to be return so it's going to be get dr presses for code first code. Alright, let's try that. Right A, up A, right, up A, down, down, down A. Let's see if that's correct. There are 3 shortest possible sequences that would cause the robot to type 029A. So they said, okay, so right A, up A. Yeah, that's always the case. And then up A. Oh, I said up right A. And then down down A. Oops. So we've not... Oh, we went right up. And they went up right. What button was... So, what was the second one? 2. And we're trying to get to 9. It shouldn't matter. But they said these are all the shortest paths. Up, right. Up, right, up. Right, up. Oh, wait. Right, up. Okay, no, we do match the first of their sequences. Right, up. A, down, A. Yeah, okay. Alright. So that's correct logic for that. So now we need to fill in the second of the methods. Get dir presses for dir given a sequence. Alright, so this is some ways it's a bit simpler. So we start at A. Hang on. There's one important thing here. Do we need to end A for the numeric movements? No. Okay, so that's a slight catch because then we don't. I'll go read through all this again. No, we don't need to return to A. So we kind of need to specify where... I know, but we will always finish on A. Because we always end with a button press. In all numpads, in all directional pads, won't we? Because you always end with an input. Yeah, okay, so it's fine then. We can always assume we're hovering over A. Because the very last thing you do on the next layer you're trying to control is hit a button. Okay. So it's similar logic basically. I could probably actually copy this. Pos equals numpad A. So this is dir pad A. So for car in sequence, dest equals dir pad is basically the same, isn't it? We should just specify it. You know what? This should just be one method, and we can specify numpad or keypad in the method itself. So we can get. So it's going to be get presses for pad. Get. We always get dir pad presses for a given pad. Sequence and pad. Alright, so pos equals pad A. Alright, so for car in sequence, destination equals pad car. Alright, so that's independent of which pad it is. In that case, we want to say bottom row is going to be different. No, let me have a look at these again. We just care about the right-hand column instead. So let me look at this. Yes, so bottom. So the right-hand column is always column 2. So we'll say if we're in the right-hand column... No, hang on. What am I trying to say here? We should say if we're in the first column, we do horizontal, because there's a gap below us. That's why. So if we're in the first column, we do horizontal, then vertical. Oh, but wait, the gap is different in a different place for each time. Okay. I think the cleanest way really is just say... Just have a couple of if conditions. So we say if... How about we say if the row we're on contains a gap, then we go vertical first and then horizontal. That would work. The row we're on contains a gap. So we need to say if and the gap is always in the first column, so we can say if pos 0 pos, so it's going to be pos.I 0 not in pad.values. So we're saying there's a gap here. Wouldn't it be cleaner if we just said gap? It added a gap to the pad. No, because you'd still need to... Okay. That is actually the best way. We add a gap. Can you just do a none? Numpad 0, 1, 2, so it's going to be 3, 0. Alright. Numpad. So let's put it in order. So it's going to be here. None. Pause 3, 0. 7, 8, 9. Let's actually put the line breaks at the right places. 4, 5, 6. 1, 2, 3. None, 0, A. Like that. And then for the dir pad, it's going to be 0, 0. So it's... Hang on. So it's like... None. Pause 0, 0. Okay, that looks cleaner. And now we say if pad none. Can we even do that? Use a none as a key? We'll find out. If pad none dot I equals pos.I. So we're on the same row as a gap. Gap, do vertical moves first. Otherwise, do horizontal moves. And that's efficient because we've got the gap there. And then we don't need that. Alright, so result. Alright, let's test if we get the same results. It's going to be code 0 numpad. Right up. Right up. Right A up A. That part's always the same. Right A up A. And then we are going right up up. And then it's A down 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 A. Okay. So that works. And now we want to say... So S equals that. And then let's say S1 equals that. S2 equals, we basically want to do this again, but S with dir pad instead. Alright. Let's see if this works. I mean, there's lots of different possibilities now, but let's just have a look. Right, down. Hang on. So down, right, A. Down, right, A. That matches. Okay, so we've got a sequence. Hang on. And then it ends in A, of course. Their sequence is... Let me just put it here. This. And ours is this. Same length. Wait. Almost the same as well. Down, right instead of... Okay. I think we're good. Okay, so in the end, what we actually do is... How many layers do we do here? I'm gonna look at this again. So there's the first numpad. Okay, so we've got for code in codes. So sequence 1 is that. Sequence 2 is that. There's a description, you gotta... So the high levels of radiation means we have to go to the next one. So S3 equals that. And then the minus 40 degrees means we go one more. We'll see if we've got the right length here. So this is ours. And theirs is... Same length. Okay, looking good. Alright, so for codes and codes, and then what's the result we want? We want the complexity. So we want complexity. Okay, so we've got these equals length of S4 multiplied by the numeric part of the code. We can assume it always ends in A, I suppose, so it's going to be int code complexity plus equal that print complexity. All right, 214454, is that the right input? Okay. Not correct, it's too high. What is the sum of the complexities of the 5 codes on your list? Alright, let's try the example. I'm worried about this shortest sequence thing. Is it really the shortest sequence? I don't see any fault here. Alright, we'll test. 126384. Correct? Oh no. So it's 126384, and this one's our input. Let me check I've got the input right. Okay. Yeah, it looks right. 7808. 802 973. 214454. Fuck. What strange situation do we have here? Is there any situation where we wouldn't start at A? Hang on. Result.append A is at the end. But yeah, we always end in A. I don't like this none. Let's just change that. Not that it will really change anything, but let's say gap. If we're on the row with a gap and we're going to another element, I can't think of any situation where we're creating where there's a definite order where we have to go do the verticals before the horizontals or vice versa. Apart from the thing about the gap, I don't want to write a shortest path algorithm. It shouldn't be necessary. Have I definitely got this correct? 7, 8, 9, 4, 5, 6, 1, 2, 3, gap 0A. And then dir pad. Did I use... I don't know what to do then. So why did the music stop? One, two, six, three, eight, four. Let's check the example again. One, two, six, three, eight, four. I know. It's got to be a catch. Like, is there like a from one button to the next? Is there a path we kind of overlooked here? So if you're staying in the same place, you're never going to stay in the same place because you always have to go to A. Oh my god. No. That wouldn't be. You always have to go. Hang on. Hang on, I don't think this assumption about always starting from... Ah, wait. Between you're typing all the codes in sequence. The only one where your starting position will actually change. Hello, Brighton Swan. How good at programming do I need to be to solve these problems? It looks pretty hard. You need to be good at like mathematical programming, so to speak. So it really, you don't have to be good with like software architecture or like the kind of programming you would normally use in software engineering. But you do have to be good at the more academic side of computer science, which is kind of different. So it's kind of difficult to explain because you need some more mathematical knowledge. There have been things which come up. Pathfinding has been coming up a lot this month. But sometimes you need some number theory, like Chinese remainder theorem came up once. Is it like competitive programming problems? Sort of, but it's less. So a lot of the popular competitive programming sites focus very heavily on algorithms from like academia, like complex algorithms. Here, you usually don't need to know algorithms, you need to know data structures, and you can usually come up with algorithms on your own, with the exception of some core algorithms like breadth first search and depth first search, which is, you kind of do need to know those, but you don't need to know actual algorithms. Like, for example, I don't know, like Padain's algorithm, which is something for solving some sort of dynamic programming or something. You just need to know paradigms and data structures in general. Eric tries to construct these problems so that you could basically come up with the concept yourself without having to know like a textbook algorithm. So I think the problem here is that when we type the code, this whole method works for one code, but when we're typing 5 codes in sequence, it kind of matters where our finger is. Now, I find it strange that the test case passed, though. Alright, so when we finish typing a code, no, but the codes end in A, so the problem I think is present isn't actually present. The codes happen to end in A, which solves that issue. Confuse them. Zero, 2, 9, A. Let's just map out in my head where we would go. We'd go to 0, 2, 9, and back down to A. And like, if we're in the same column or the same row, then these for loops are redundant. But we still just, Pause is test. Result.append A. So let's have a look at these. 980. We'll go 980, okay. Then we've got, and I've got to look at my inputs. So 341A, 3, 4, 1, A. Then we've got 083A, 083A, 802A, 802A, Nine seven three A, 973A, 780A, 78. Hey, what is the problem then? Hello, DJ. Codes. I thought it was fine, and it's passing the test example. It's not passing the my input, which is really strange because they're of the same order of magnitude. What did it say? It was too high? Oops. Yeah, it was too high. Alright, let's try printing what we're actually gonna... Okay, so we'll do print code, print S1, print S2, print S3, print S4. So we're using, this is the test examples. Print length of S4. So the numbers we get are 68, 60. Let's check these individually. 68, 60. 68, 64. 64. 68, 64, 64. That's correct. Why is... Why is S3 the same length as S4? Why is it identical? Wait, something's wrong here. Oh, fuck. That should be a... How could that possibly have worked? Why did it work for the test example? That should be S3. Why did it work? Oh god, what's going on here? Right, so that was a typo. So S4 has the best reaction to code. So S1 takes the code. S2 takes S1. S3 takes S2. S4 takes S3. And then we get S4. So now we get this. But now that breaks the test example. Do they have a different number of robots? Or was it actually S3 we needed? No. S1, S2. Oh, it is S3 we need. 1, 2, 6, 3, 8, 4. That's the correct answer for for the test case. So it's S1 and S2 are the two intermediate robots. S4, S3 is us, the human, well, the elf, pressing the buttons. So now that is the actual input. 214454 is the same. What the heck? Let me try that number again. There's a remote possibility that I pasted it in wrong? Well, no, it's too high. So there must be a shorter path on one of them, and it's just really obscure that we wouldn't have seen it. I don't see how that could possibly be the case. So that was invalid. Take that one out. So do that. Take that out. That's 3. So it's weird because our typo happened to make it right by omitting S4. Okay, so we go. This is what we're claiming as the shortest sequence to do to each of these codes. So it's down, right, right, A, right, right, up, A, down, right, A, right, A, right, right. Oh, you know what? No, because we always go back to A, so it shouldn't matter which order we do rights and ups and stuff. Would it? I can't figure this out. I mean, I could write a shortest path algorithm, but I can't see a situation in which this would fail. 341A. So the longest one was this one, 802A. So we're saying up, 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 right, A. Is that right? Up, up, up. Left, A, correct. Is there any reason we would go left, then up, 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 A? No, because the next robot will have to do both the left and the 3 ups, and either way. Up, 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 left A. Then we've got down, 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 A. So that's 0. Down, 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 A, correct. And then up A is 2. And then right down A. Right down A. And would it be better to go down right A? No, because it doesn't matter. Oh, but there is a case where it does matter. Oh my god. Okay, so I think so. Let's say we wanted to type down right. We could go down. We could go do the right first and then do the down, then return to A. Or we could do the down and then the right and return to A. So it doesn't matter which way we go. What does matter is whether we go via this up to get back to A, or go via this right to get back to A. And that matters because you know, why does it matter? No, it doesn't matter. The only thing we want to avoid is lefts. But if we have to type a left, we have to type a left. That's unavoidable. I think there is a catch here. I can't figure out what it is. There's always going to be either ups. Okay, so let's consider 4 possibilities. Either we have to press a sequence of downs and rights. So either we go right, do the rights, then the downs, then return to A. It doesn't matter when we're returning. Does it matter whether we go up A or right, up right or right up? I would say that they're equivalent. All right, so down right is fine. Down left, we would go here. It doesn't matter really which order we go in. Up right, so we can go what about up left? So either we go first to the up, so that's a left to get there. Then we go down left. So it's left, down left. And then right, right up. Left, down left, right, right up. Or if we went down, left, left. Then we go right, up, right. Ooh, that might be the catch. Now the problem here is left is an expensive operation because you have to go all the way over there. So if we went left, down, left, versus going down, left, left. That will, if you went down, left, left, you get to group the lefts together. And why is that better? Because then I think it might be something like that, but I don't quite get it. So what are we doing right now? Does it prefer... If we had lefts and ups, does it prefer to go for the lefts first or the ups first? If we're in the gap row, we do downs. We do the downs first, and then we do the vertical first, and then the horizontal. But it might be better. Yeah, you know what? I think so if we're in the gap row, we have to do this. But if we're not in the gap row, it's not obvious what the best route is. I reckon it all stems from whether we do the lefts before the... Alright, let's go back. So when we're in the when we're on the numpad, we've got 4 possibilities. Either we go up right, down left, up left. And when those happen, it's not obvious whether we're just arbitrarily, unless we're in the gap row, in which case we always do the ups or downs and then the lefts and rights. But when we're in any other arbitrary place, it's not obvious whether we should do the horizontal first or the vertical first. I reckon we should always... We want to... And indeed, we do pick the horizontal first. Maybe we should be doing the vertical first whenever we can. I think we just want to avoid doing lefts as much as possible. No, but we have to do them anyway. I don't get it at all. I feel like there's something wrong with this. I think it's something to do with because of the fact that left is far away, but I can't see an example which way it would fail on. What if we swapped orders around? Like, if I swapped orders around and somehow find the answer changed, that would be a clear sign that we've not actually found the shortest path. So if I said if... Let's say if we're in the same column. Let's go with column instead. Column has gap. Then we want to do the horizontals first. So basically be this way around. So let's try it this way around and see if that changes anything. Oh god, it changes things. Why? Okay, fine. I can't think of... I can't get my head around what example would cause it to be less, but it is actually not the shortest path. In which case, either we hope that this is the right answer, Or we're actually going to need a proper shortest path algorithm. So that is less. No, it's too high. It's still less than that. Alright, fine. We need to actually do a shortest path algorithm then. Damn. But does that not... So on the test example, 127900. And that gives a higher result for that. So it's actually not obvious which way around you want to do it. Okay. Okay, fine. We have to go back to the drawing board. So how do we actually do this then? To get the minimum number of... Ultimately, we want the minimum number of numpad, final directional pad presses. But that'll affect what... Maybe we just write a shortest path algorithm from scratch. So how would we do that? So state would be... All right, let's do that. So we're not allowed to move the hand off the grid, are we? Where no button is present on the keypad, even for an instant. Right, we're not allowed to move off the grid. So define, suppose it's BFS, although we might even want A star. I feel like this is gonna take a long time. There's a lot of layers here. Oh, don't have the thing open. All right. So given a state is going to be where each of the hands are. And we're trying to minimize the number of presses we make on the final DIR pad. So there's three robot hands. 3 robot hands. So a state is going to be basically... start equals A. But we also want the amount of code that is typed so far, because that's part of the state as well. So just empty string. Okay. U.append start, distance start 0. While q. Alright, so we want to say current equals q.pop left. Alright, so then we want oh, this is so confusing. So we compress up, down, left, right, or A. So neighbors equals those, basically. This is straight up a Castle of Dr. Brain puzzle. Is it? Maybe that's where the inspiration was from. Have you finished this already? Alright, so let's try and type that code. So possible neighbors are so whatever we press is the next robot along is what we're affecting. Okay, fine. So we're affecting robot 3. So we can say for neighbor in... No. Okay, we'll just say we're either telling him to go up, down, left, right. So we say, or we're saying A, I suppose. So robot 3 pause equals dir pad current 0, 1, 2. So that's where robot 3 is currently looking. Or should we just say, or just describe these as pauses? Pause, so going up will be -1, 0. Going down will be 1, 0. Going left 0, -1. Going right will be 0, 1. If neighbor is pause, we're telling R3 to go to this destination. So it would be R3 pause plus neighbor. Alright, we should just remove these gaps then. Just have those, because we can go off the side of the board as well. So we say if R3 dest, so that if we're giving him a vector off the side of the dir pad, not in dir pad dot values. Continue. Could make this more efficient by having, doesn't matter. All right. So we're moving him to a valid pause. So let's just expand this. R1, R2, R3. Code so far, let's call it code typed, is that. Or okay. So basically the new state, if we type in this left, right, up, down, will be... Oh, we don't want to call this neighbor. Call it... R input. That's the L. Then we've moved him to another location. All right, so the final neighbor will be R1, R2, R3 dest. The code types will be the same. And then we want to append this neighbor. This is going to be a triple layered. This is going to be really complicated. It won't take that long. And then we have to do this. Just make a little helper method. Define handle neighbor. And we just do this. Just so we don't have to keep typing that segment. So we say handle neighbor current. Right. So that is correctly handling that. Else, if we're pressing A, then we're basically telling R3 to press whatever he's looking at. So we want to look. We're going to need a map here. dirs equals to pause. So basically, it's going to be this. Up, down, left, right. Okay, go back to up, down, left, right, A. If R else, so okay, if our input is A, do something, otherwise do dirs our input plus R3. Okay. Right, so if we're pressing A, then we want basically R3 to do whatever he's looking at. So basically it's this whole thing again. This whole loop. But it's going to be if R3 input is A, do this. Wait. No. If R3 is A, do this. Otherwise, it's going to be R2 dest equals dirs R3 plus R2. Neighbor equals R2 dest handle neighbor. Okay. Then when you look at this layer, if R3 is on A, that means we move to R2. So basically do this again. I know this is now really a stupid way of doing this, but started. But we say if R2 is A, do that. Otherwise, we are moving R1. Okay, so then we do that, and then this is the final layer. If R2 is A, we're telling R1 to press whatever he's looking at. So, new code equals code typed plus R1. Wait, R1 is not a... Hang on. Something's wrong here. These are not posers. So this should be the... should be the IR pad. This should be dir pad. This should be numpad, because R1 is a numpad. That will be a numpad. R1's destination is not a valid numpad value, continue, blah, blah, blah. Okay, so now, here, new code equals code typed plus R1. R1 is just the character we're looking at. If new code, if not code, so it's going code dot starts with new code. That means we've typed an invalid code, so we don't handle this case. This is going to be so slow because we're going to type a bajillion different codes before we get the right code. I don't think we should be doing it this way. It should be Dijkstra, shouldn't it? No, not Dijkstra. It should be A star, if anything. We won't actually add a bajillion different things because we won't be typing invalid codes in the first place. But we will keep moving these robots around. So we should be using A star, to be honest, but I can't be bothered to type A star. We'll see what happens. So this is a valid code. So we're now going to say neighbor equals, so nothing changes. We've just pressed A across all the robots. And new code is that. Then handle neighbor. However, if new code equals code, we're done. We want to return dist current plus 1. My god, that's horrible. Alright. Let's see if this actually works then. So, back to the drawing board. We want to just move this down. Well, we'll keep that as it was. Maybe there's still a use for it. Okay, complexity equals 0. For coding codes, so we want BFS self code. So everything's determined from the code. Okay, so BFS complexity is gonna be BFS. Well, what? No. It's just code. Code times that. All right, try that. Key error. DIRs are input. Oops. Okay. That's 1, 2. Key error, pause, I equals 1, J equals 2. DIRs are DIR pad R3. Wait, no, that should. Oh, damn it. We're indexing on the characters. Whoops. So some of these are the wrong way around. So these are the characters. R3 destination is going to be the pause. Oh, okay. I get it. Can we just map this the other way around? Numpad inverse equals v to k for kv in numpad.items. That way we can go both ways easily. Okay. Okay, so we want to say this is the worst code ever now. R3 dest equals DIRs so that interprets our input. That gets us the vector, so that's now a vector. If that's out of, so this should really be DIRs inv. It's invalid. Neighbor equals RS, so it's going to be DIRs inv R3. Good typed. All right, and then we have to do the same here, so it's going to be. But we have to check. So R2 is DRS plus DIR pad R2, correct. R2 test not in DIR, continue. It's going to be R2. And then here, and this we use numpad instead. Okay, if here we use numpad R1, no, yeah, R1 dest, that, and then when we go to this one, we don't need to do anything. Okay. E error A, R3. So R3 was A. If our input was A, what? Oops, that should be dest. That should be dest. Yeah, it's always dests. Clearly we need lots of helper methods to do all this. All right, 203814. Oh, wait. Okay, now let's test the input example. 126384. That sounds right. 126384. Okay, so it's correct for the test example. And that ran instantly, to my great surprise. Are we definitely... We did comment out that stuff, didn't we? Can we just comment out that I don't want to be using that? Okay. Sounds a bit low. That's the answer for the test case. But you will have had a different input, won't you? $203,814. This is what I tried before and it was too high. So this is lower. Correct. Oh man, I do not see why my heuristic would not get the shortest path, but I can accept that there's a weird thing with when you're going left up instead of up. I don't know. I can't visualize it, but if I just trust the BFS search, that gets me the right answer. I just don't know what. Later on, I'll look in the forums and someone will explain it. I can't be bothered to figure it out now. But there are cases where it's not obvious what the shortest path is, I guess. Alright, part 2. Right, that was the hardest part 1 so far. Just because I had to resort to using BFS. I thought I had a good heuristic for it, but I didn't. Just as the missing historian is released, the historians realize that a second member of their search party has also been missing this entire time. Oh, bollocks. This could be generalized to 25 directional keypads now. We can't realistically use this same method, can we? A quick live form scan reveals the historian is also trapped in a locked area of the ship. Due to a variety of hazards, robots are once again dispatched, forming another chain of remote control keypads, managing robotic arm-wielding robots. This time, many more robots are involved. In summary, there are the following keypads. 1 that you are using, 25 that the robots are using, 1 numeric keypad that a robot is using. Okay. The BFS should still work, I guess, but it's just more branching and more horribleness, but... We'll just get lots of neighbors where we're moving, because it's BFS, we're going to move things around that we don't need to, and that's going to waste time with 25 layers, but it might still be fine. So we have to generalize this method first to basically n intermediate robots. That will mean we can extend this to 25. And that will actually make my code look much better as well. So I think should we say inter robots? So we're talking about the intermediate ones, not the one which is at the numpad. So it's going to be... Alright, forget this. Unless... I mean, we could still be onto something with this if I could just figure out what the correct heuristic is. I don't know what weird example results in a longer path. Doesn't matter. I think this might work. Alright, so we want start equals, so it's going to be that plus, so it's going to be so it's going to be that times num into robots plus 1 plus that tuple, I guess. Now, just changing that, okay, just make sure this still works. So we're saying 2. That should still work. Fine, okay. So when we unpack this, we've got num had robot equals the first one, and then we've got inter robots equals current 1 up to and excluding the last one, and then code typed equals current last one. So just basically got to look at the cases. So we say for our input, do we just want to type this all again? Probably would be for the best. Okay, so but it's going to be shorter now because we're just handling 3 different cases. So there is the case where it's all A's. Then that goes to the code stage. All right, so we hit A. let's say all the inter robots are A. If inter robots all X is A for X in inter robots, that means numpad robot is gonna hit his thing. So it's basically this code here. Whatever R1 is, so it's gonna be that. Neighbor equals, so it's going to be maybe it's just cleaner if we just pack this up like this. We say it's going to be comma and then we'll just have the num inter robots as one string. Just say A times that, and then that. Yeah, that's better. So num inter robots will be a string. So we've got current. So we've got numpad robot, inter robots, code typed, like that. All right. So for our input in these, if we hit A, if let's just say if inter robots equals A times that, so that shouldn't be +1. Then we're just typing a code. New code equals numpad robot, blah, blah. The new neighbor will be basically that, except this will be new code. And then that will be the same. Handle this neighbor. All right. Else. We basically wanted to find which robot is the one that's going to be affected. So it's not all A's. So we want to basically find the index where it stops being A's. So let's say but we're starting from which way round are we having these? Does it actually matter? We say the first first one is the one closest to us, so we're controlling the first one. Yeah, because then... And the last one is controlling the num. Yeah, okay, we'll do it that way. So... How long have I been going so far? 2 hours. Alright, if I can finish this loop down here, it should just work as before. At least for 2 robots. We'll see if it works for 25. Okay, so... let's say I equals 0 while inter robots I is a I plus equal 1. So at this point, I is looking at the first non-A. So we have basically I, whatever I is, we'll have I A's pressed. And the next robot after them is the one that's getting told to press the button. Alright, so there's one case we need to look out for. It might be that I is the final thing, in which case we're controlling the numpad robot. So if I is so it's going to be -1, so that means we are they're all pressed, they're all A's except for the last one, so we're actually hang on, we can also say dr pad input equals to robots I. So that's the dir pad input fed to the next robot. So if it's that means it's a special case for controlling the numpad robot. So we're saying basically this logic down here. It's going to be like this. R1, so it's going to be numpad robot dest equals, so it's going to be dir is that plus numpad whatever. So that's the vector we're going to. If that is not valid, continue to the next iteration of this for loop, right? Yeah. Otherwise, we are now changing this dude. So it's going to be that. This will stay the same to robots. Code typed. Okay, handle. Otherwise, in this case, I is not pointing to the very last character. So what's going to happen is we are going to affect the I plus 1th item in InterRobots and change it. So affected robot equals InterRobots I plus 1. And affected robot is the character he's pointing to. Now we basically have to do this similar logic here. We have to say, well, actually similar to like this sort of. We say affected robot dest equals, it's going to be dir pad of whatever he's looking at, plus the direction Alright, let's simplify this. Let's say movement or dir vector equals dirs that. Just use that instead. Okay. So affected robot dest equals that plus that. If affected robot dest is not in a valid place on dir pad, not numpad. That's why we have to separate these two cases. Continue. Neighbor will be so numpad robot stays the same. The code type stays the same, but the intermediate robots will be basically InterRobots up to I plus 1 plus the new character that this guy's looking at. It's going to be this plus, because this might be in the middle, we need to just add the rest of these. I plus 2 onwards, if there are any. And then code typed. Okay. Then we are at this bit here. If our input was a direction. Basically, reusing this snippet of code. It would have been cleaner if I somehow equated that to... Oh, it doesn't matter. Alright, so basically just repeat this. So if else... So affected robot we know is InterRobots 0. So this one would simply be dir DIS with R input plus DIR. Okay, then this stays the same. Blah, neighbor equals. So the neighbor will be similar to this. But it will be that plus into robots 1 onwards. Yeah. Oh my god. Right. Code types. Will that work? It does actually look... I mean, it's about as long as before, but it is cleaner now because we basically have 3 core cases, which correspond to these if conditions. And it's good that we've separated them out that way because one of the conditions decides whether we're using numpad or dir pad. The other would be whether we're outputting a code or not, and the other would be basically deciding which robot is going to move his hand. So the question is, if we now just run this with 2, will we get the same answer? Something's going to break. Okay, we've got the same answer as before. Are we definitely using that? Here we are, okay. So that's part 1. $25, here we go. This might take ages. Now the problem is there's going to be a lot of invalid neighbors where we're moving their hands about just because it's a close neighbor. So this is why you would want to use A star, which will force them to only always affect the later robots closer in the path which already has the code partially filled in. I could adapt it to A star. I don't know how close are we getting to the code. Are we ever even typing something in the code? I think there's too much branching here. We're definitely going to have to do something. Hello, Olympus Tiger. I really struggle with day 20, part 2. I'm trying to run it now, it's too slow, but I can definitely see ways I can speed this up. It's just... I don't think VFS is really the right answer now, with 25 robots. I don't think we're typing anything here. So... Also, 25 is wrong. It should be 24, shouldn't it? Hang on, let me look at the thing again. We have 25 robots altogether. Oh yeah, no, it's 25 intermediate ones and 1 on the numpad. Okay, so it's 25. 25 plus your own. No, it's actually 25 plus plus the keypad one. So it's 26 robots altogether. But they're giving us 25 intermediate ones, one on the keypad and one of our own. But the way I wrote the code, 25 is fine. Alright, now we're going to have to adapt this to A-star then. It's not that hard. I mean, once we know how to do BFS, we just need to change the priority queue, this to a priority queue. Alright, let's first change it to Dijkstra. So that just means we have to do this input from queue port priority queue. Okay. Then we want queue dot put, so we need 0 start, so you always put the distance in, and then when you do this we do dot put dist neighbor neighbor. Well, there's one thing we need to check here as well. If neighbor isn't dist, return. Okay. If neighbor isn't dist, hang on. The only time we won't add it is if neighbor is in dist and dist neighbor. Okay, so we say neighbor dist equals dist current plus 1. Is if we found a better thing before, then we return. So this neighbor is now updated to be the best thing we found so far. Lazy deletion. Q dot put that. So Q dot get. D current, that will get the distance out, equals that. If dist of current, if we've later found a better path to this somehow, result should be in the trillions. Let's just see how far we can get with this first. This current is better than what we found so far. Then skip this, that's just lazy deletion. Alright, this should still work for 2. Or not. Alright, what's happened now? Start with 0. Well, this is less than or equal to. There we go. Alright. That's BFS. So if we want this to be A star, we just have to say the heuristic is just going to be the number of code presses we have to, the number of missing code digits we have, basically. Because that would mean you have to press a button somewhere at least four times if you have 4 more code presses. So q.put 0. Okay, so we say define the heuristic of a state typed code equals state return length of code minus length of typed code. That's how many characters we have left. So we want so when we put it on the queue, it's got to be dist of start plus h of start, and then handle so it's going to be dist of neighbor plus h of neighbor, h of neighbor. All right, because that's still that's not finishing now. Hang on, no, that's not how you do it. Stop. No, that is how you do it, isn't it? So the heuristic's always got to be an underestimate. So the length of code minus that. So it's going to be 4 at the worst case. Ah, no. Q.put okay, just put return 0. Just make sure this isn't somehow breaking it. So this should just be the same. 203 814. Why would this break it then? Should be prioritizing states where we've already typed the code partially, and it's correct. It's partially correct. That's weird. Okay, A-star doesn't work then. That's weird. Let me just check the A-star wiki if maybe I've done it wrong. So you start go. G score is the distance, F score is heuristic applied to the start state. And then G score when we're wait, I changed that to less than or equal to. Is that correct? Yeah, that's correct, because we only want ones where we are better than what's known. So G score will be that, and the F score will be that. And you put that in front of the neighbor. I don't know then. Why would it not work? Alright, anyway, I mean, this approach is probably not going to work. Anyway, we need to figure out what is the pattern. Because my original idea, if this was correct, then that would have been it. We would have just extended to 25 easily. So why didn't this work? I still don't know an example where it fails. I guess there are situations where I think I've always been assuming that for any given robot, shortest number of button presses is optimal. But that's not necessarily true overall, because a shorter number of button presses in the robots which are like closer to the numpad may not necessarily equate to a shorter number of presses from a robot further down the line. I can't think of a possible example, but apparently that may well be the case, because that was what I was assuming when I wrote this. So unless there was an order of horizontal verticals or something that's perfect and satisfies that quality, then, but I don't see what. I don't know, and I might not have time to finish this off today. Let me look at these numbers again. Alright, well, guess we'll go back to BFS then. For some reason this doesn't work, or just call it Dijkstra. Alright, we'll just say state return 0. Okay. So I'm curious about these numbers here. Two, 4, 5, 5, 2. 5, 4, 7, 8. 5, 6, 1, 4, 0. 6, 6, 1, 6, 4. 5, 1, 4, 8, 0. They're wildly different. That one's only 5, 4, 7, 8, and that's just depending on which keys you're pressing. After you typed one number, then what? What state are you in? So, you've typed a number, all the robots are now on A, except your robot is now looking at a number. So really, you just want to know, so isn't that independent? So we don't actually have to do the whole code. We just want to know if our number robot is looking at X and we want to type Y, we want to know the shortest path to do that. And if we can figure that out, then you can do these in sequence. So you can say, now we're looking at this and we want to type the next number. 7, Does that hold? Yeah, because all the robots are back to A, so I would think so. Let's see if that works. Then we'll be one step closer to figuring out how to break this up. So we're saying can we go back to what it was like without just go back to regular BFS? There. Is that it? Okay. So I'm saying instead of this, it should really be given a car that we want to type, a number of intermediate robots, and let's say numpad robot start, that tells us where he's pointing. This just changes the starting state. They are all on A. We don't even need that. And then this is all the same except if they're all A, then if numpad robot is, I'll just call this desired car just to clear it here. Desired car. Don't need any of this. We never putting a neighbor here, so it'll be return this current plus 1. And that's it, right? Alright, does that work? Oh, but then we need so just say 1 equals so it's going to be BFS is going to be, we want 3 and we are at A. So everything is really down to the vector that you want to follow. And if you were at Oh, why am I on 20? Whoops. If you were at... Where's the... If you were at 5 and wanted to go to 9, it would be the same as if you were at 2 and wanted to go to 6. Like, there's no difference, is there? With the exception of whether you're going over the gap. I'll finish this off. Where was I? Okay. So R1 equals BFS3. R2 is... What? Yeah. So 3 from A. We want... Wait, why am I typing these in manually? I meant to say code 0 from A. And we want code 1 from code 0. In other words, we're saying just say okay, so it's like this. And then for I in range 1 length of code complexity plus equal BFS code I using code I minus 1. And then total complexity plus equal complexity times that. All right. Oh, I left that running. That's why it was slowing down. Not enough values to unpack. Oh yeah, because we don't need this anymore. $66? What the heck? Now what went wrong? We're coding codes. Meaning of the universe. 66? Why is that? Complexity. Does that even make sense what I said? So when you would output a code, all of the robots will be on A's again, except for the numpad robot. So to start the next chain, you would simply start from that. What's wrong with that? Total... Oh, I'm printing complexity. Whoops. That's why you should refactor variables by right-clicking and clicking refactor, rename, which I haven't done once this entire month. Okay, fine, we get the same answer. Okay, that's good. That's a step in the right direction. Code doesn't matter. Single characters matter. Then what? So that kind of extends to the directional pads. Like if you knew... If you knew... So if we were to hash... Oh boy, how... I can sort of see how to now extend this to like a sort of like a caching method where if you knew all possible movements for a given robot on the directional pads, like if the robot's on up and you want him to press right, then you wouldn't need to keep recomputing all the subsequent robots. You would just know the number, and you just add the numbers together, and then that will then we can get to really big numbers that way. But I kind of want to stop soon. I need to go eat. So I might, for the first time this month, break this into parts and carry on next time. How long have I been on this? 3 hours. Okay. Not too bad. It's nowhere near as bad as previous years where 5 or 6 hours was well, that was usually the worst case, but pretty sure I'm close though. I just need to clear my head and go back to the drawing board with this new idea of numbers being defined by a vector of movement, basically. But still, yeah, I'm still not sure about this. Maybe I can just try right now like a sort of caching approach. Yes, we say define define I can't think of a name. Fun. Funk. So we say the robots are numbered from 1 to or 0 to n. So we know which. So for a given robot, ID. For a given, we know where he is right now. Current key, and we know where we want to go. And we also want to have that pressed as well. Dest key. So those are the 3 inputs. And we want to know the shortest number of my key presses that will give us this. Right, so also we're going to be caching this, so we say so we're just caching 3 values here. So if we can find all possibilities, it'll be 25 times those, then that should work, right? There's not many vectors that we need to go cache. If we can work out every one of them, then we should just have the answer. So okay. Which pad are we using? Pad equals pad inv, because I use those, equals numpad inv if robot ID equals 0, else it's just gonna be darpad inf. Alright, so that's the pad we're working with. That. If oh, we also need one more value here, basically total robots. That way we can actually do part 1 and part 2 using the same cache. Why not? So if robot ID equals the final robot, the one that we are controlling, then we know the answer here. It's going to be Alright, DJ. Have a good rest. I feel like I might actually be able to get the answer now. So if we're looking at the final robot, we know exactly what we're typing, so we can just say delta equals... Wait, so... current pos equals paddinf current key. I guess we could do it this way. Dest pos equals dest key. But this... Interesting. Okay, I don't know. The number of key presses is basically just so delta equals dest pos minus current pos, and then the number of key presses return. So it'll be absolute value of delta dot I plus absolute value of delta dot j plus 1 for the because we need to press A. Okay. So then the general case, we need to look at the horizontal and the vertical, and we want to decide which order we actually do those in. And we could say we chose both orders. That might not even be enough. So we might need to actually try all possible sequences of ups and... So if we need to go upright some number of times each, we might want to choose all possible orders in which to do that. That would be really strange. Do we really want to do that? Maybe that's what we do. Alright, so so we need to find the sequence we need to follow, basically. Also, this is like... we can compute this beforehand. So we want to follow this vector here. So the sequence is like... or in range absolute value of delta dot I but we don't want to cover the gap. That's I guess we'll have to do a gap check for each of these sequences, so we'll have to do... Yeah, we can do that. Seek dot append, so it's either gonna be so it's gonna be a that if delta dot I is negative, else down, and then so this is just one sequence, so we want to try all shuffles of this basically. Sequence dot append, so left if delta dot j is negative, else right. Okay. And now we need random dot something. I need to Google this. Python ITA tools. Not random. We need it's not random. We need ITA tools, permutations, combinations with replacement. I never remember what any of these mean. It's not any of these. What am I trying to do? Combination. It's not combinations. I want all shuffles of this sequence unique. Unique permutations of this sequence. Let me have a look at permutations again. Otherwise, we just take all permutations and just filter out the ones which are equal. That's not quite what we want, but... Alright, let's just try this out then. Let's say... I leave that for now. Leave that out. I'm trying to get permutations here, so we want... Alright, just comment all this crap out. Pretty sure we're not going to be using that again. Okay. Print permutations of, let's say, left, right. Let me just see what that does. For x in permutations print x. Left, left, right, left, right, left, 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 right. So it does include duplicates. Okay, fine. So we just take a set. I thought there was a more efficient way of doing this, but it won't actually matter. I think it's still within a reasonable amount of... Okay, we'll just do that then. So we want... That's the sequence. We want... For R, let's say, in set of permutations of sequence. Alright, so every unique ordering here. First, we want to check that we don't cover a gap. So, pause equals current pause. We know that this will get us to the destination. Pause. The number of steps okay, for direction in so for the first direction, we have to get the next robot to A. Sorry, the next robot is on A. We need to get the next. So it's going to be this basically, but function robot ID +1 from A to this. We need to get it to this character. All right. Then and that also includes the one extra for pressing it. So that moves us like that. Hang on. Or there are key in enumerate R. Alright, just do it like this. Steps plus equal that, but we want to say so the next robot will be on A right now. We want to move it to the dir key and press it. So it's going to be A if I equals 0. Otherwise, what will it be on? It will be on dir key, right? Else the previous one. But oh, okay, I see. Previous. So we need to say No. We know what it is. It's gonna be. And then pos equals current pos plus this just to find this outside. dir key. Okay, so this is saying the next robot will be forced to do that. Move from A, where it was, to the dir key and press it. It'll take that many steps, and then we will now be pushed to this new vector. And now we just need to check that this is not a gap. If pad, if what were we saying? We're saying if pos not in pad in, this is a gap, so break. We're not allowed to use this R. Else, if we never broke, then this was a valid wait, what? No. Pos plus equal that. Oops. Pos plus equal that. So if this was if we get this far, that means this is so trying to find the best set here, aren't we? This is a possible number of steps. So after we've done this, hopefully, I mean, there is always a path that will follow this sequence to get there. So there's always going to be something here that doesn't cross a gap. So what do we do? We return min candidates plus, so that was just to get us into position. We also have to we have to account for the final A push. So we have to say so it's going to be whatever we left it on. We have to bring it back to A. And press it. And that will force us to press this. So then we just return min candidates. that the whole thing? Okay, let's test it. So, go back to part 1. Total complexity equals 0. The coding codes. Complexity equals, so we want to go from func okay, num robots equals 3, 2 intermediates. So it's going to be func so robot ID. We want to move robot ID 0 from A, where he starts from, to whatever code 0 is. And we have num robots altogether. And then for each of the remaining code pieces, we want complexity plus equal. So we are currently on code I minus 1, and we want to get to code I, that many robots, and then total complexity is that times that. I don't know. Let's see. Crashed. Current key. Pad inv current key. Key error A. Error A. What? Is A not in there? A is in there. In both pads. Inv. What? Oh, no. In takes pauses and returns. Hang on. Done this the wrong way around. Which one were we using? Current pause equals pad. And then I think we'll probably have an error at tuple index out of range. What? How can that be out of range? That's the, I want them. Oh, is it an empty set? Ooh. Oh, that's a point. If not sequence. That means we are already in the right place. Then we just want to hit the A button. All of the remaining robots are also on the A's. So it's return 1. $203,814. Same answer? Yes. Looking good. Part 2. Num robots equals 26. So 25 intermediates plus 1. So I don't see any reason why this should fail. It's just we just got more ID numbers. So it's just times by 26 essentially. All right, code. So it's just changing number robots. Like that. That was completely instant. Correct. Oh boy. Yeah, okay. I should have realized much earlier on that indexing on the robot ID is like a massive neon sign saying to cache results for or on robot IDs and not the entire vector of keys that robots are sitting on, because you've got a very clear recursive step there. That's a pretty good problem. Let me clean this up now. Just get rid of all that stuff we wrote before. Yeah, I shouldn't really have gone down that BFS path. I mean, it did still yield the right answer for part 1, but pad stuff. That. Oh boy. Oh, okay. I'm interested to see what people say about this one. This is quite a good problem. Dare I even look? I don't think maybe using AI this time. 23 minutes for both stars. That's quite high. I think AI will definitely trip up here because, first of all, that's really hard to decipher the meaning of that description for an AI, because it just is. But also, it may well not go down the use the caching path here that I've used. It may go down the BFS path. Also, my solution was assuming that if you want to go from here, let's say you've got to go up, up, right to get somewhere, then your possibilities are up, up, right, up, right, up, or right, up, up. But that's not the full list of possibilities, is it? You could also go right, right, up, left, down, or you could go right, right, up, left, left, up. You could go in a snake pattern. You could go in like in a non-convex sort of path. I just kind of assumed that all of those will be too bad. But that's not necessarily true. I don't know. It was a reasonable assumption that it would be something along those lines, and you wouldn't have to go forward one and then back one, but it could have been. In which case, you would need to find all non-self-intersecting paths within the numpad, which, to be fair, is not that many. It just means there are more to check. Okay. What was that lesson I said before a few days ago? When you're stuck and you can't see what you're supposed to do, the answer is usually dynamic programming. And indeed it is. It's all about dynamic programming and which indices you're feeding into the cache table. It always comes down to that. Ooh. Umaro and myself are ahead of the game here. We're the only ones who've done this. Nobody's even done the... Hang on, what day are we on? Yeah, 21. Yeah. Nobody's even done it yet. Even the part 1. Wait, that's surprising. I would have thought people will get part 1. You can do that with BFS or something. Okay. Captain Coda? Only 2 other people have done it. Alright. That took me 3 hours, 40 minutes. I mean, I kind of acknowledged that I may well want to go down a dynamic programming path early on, but I kind of just wanted to make that breadth first search work. I just wanted to see it working on part 1 at least. Because that would also help me understand that there are paths which are faster than the obvious approach. Which means you can't... There is no simple heuristic for the shortest path. I just wanted to prove that, and we did prove that. So, yeah. But yeah, when you realize each robot is sort of identical to the next one, it's just a question of how many robots there are after it, then that admits the most obvious dynamic programming step. Because each robot is only affected by what you do with the next one. Alright. I imagine a lot of people are still on this. Well, I don't know. I think... Is anyone even still in chat? I think everyone's fallen asleep. It's like 6 AM for some. Alright, I think I'll just stop the stream there then. That was a good problem. Well, we've got 4 days left to go. Captain Coda's not doing the rest, I believe. He'll probably do the rest during the year. Alright, now I gotta upload a 4-hour video. That'll take a while to render. So, it'll be hours before they appear on my YouTube. Alright, thanks for watching. See you tomorrow.